I repeat, for uninterrupted viewing of the slide, please pin the page of the speaker. Our speaker has still not joined. We will start as soon as he joins. Sorry for the delay. Our speaker has not yet joined. We will wait for him and start as soon as he joins. Welcome to the National E-Workshop on Molecular Visualization and Modeling using Python Programming sponsored by DBT Star College. It has been organized jointly by Department of Physics, Microbiology and Zoology of Maulana Azad College. I am Bipasha Roy, Assistant Professor of Microbiology. Today, computer and programming are doing abysmal tasks like calculating really complex mathematical values, handling and sorting enormous data, and then presenting them to us in an useful and understandable format. But before the desired output, we must make the computer understand our requirements, and hence comes the need for coding languages, which the computer will understand and perform tasks accordingly, which would otherwise require a whole lot of time and energy. I, being a biologist, always found computer language and programming very difficult to understand. But then I was fortunate enough to attend a seminar where the dynamicity of Python programming was being discussed. I was introduced to the complexity of the programming methodologies and the variable tasks it can perform, which are so much essential in our biological researches, like mathematical modeling of complex biosystem, protein modeling, genome sequencing, microarray data analysis, and a huge lot of other critical tasks. So learning Python programming is the best we can do in this period of confinement. The nationwide tense situation has restricted our accessibility to our workplace. Research is being compromised, and to enrich that, we should definitely learn something new and add some exceptional uniqueness to our work. Maulana Azad College and its DBT Star College team has made that possible. They have invited two extraordinary scientists who are proficient in this Python programming. They regularly use this technology in their research work, and today they will help us understand the programming language so that we can also add more value to our part of research. Now I request Professor Shubir Chandra Dashgupta, College Scheme and Head, Department of Zoology, Maulana Azad College, to introduce the speakers.
Very good afternoon, everybody. On behalf of, am I audible? Am I audible?
Sir.
Yes.
Yes, sir.
Good afternoon, everybody. On behalf of Maulana Azad College, I welcome all of you this webinar, which is a unique, and it is an e-workshop on molecular visualization and modeling using Python programming, jointly organized by the Department of Physics, Microbiology and Zoology, Maulana Azad College. We have mainly two speakers amongst us. Today's speaker, Dr. Abhijit Korgupta from Pashkura Banamali College, and Dr. Sugato Hajra and his research team from IIT Roorkee. On behalf of Maulana Azad College, I welcome all the resource persons for this 3-day e-workshop program. Today's speaker, Dr. Abhijit Korgupta, is an associate professor of physics, both undergraduate and postgraduate department of physics at Pashkura Banamali College, West Bengal. He graduated from Presidency College, Kolkata, and did his postgraduate from Calcutta University. His research experience include PhD from Shah Institute of Nuclear Physics, Kolkata, followed by postdoctoral work at Institute of Mathematical Science, Chennai, and Raman Research Institute, Bangalore. The current research institute of the author is in the area of computational physics and interdisciplinary application of statistical physics. He is the author of very popular book, Scientific Computing in Python, which is essential reference book for the syllabus of Python programming included in the undergraduate physics course of various University of West Bengal. He has taken part in innumerable workshops on Python programming for training teachers and researchers of West Bengal and other states of India. With these few words, I welcome Professor Abhijit Korgupta and hand over the dais to him. Professor Korgupta.
Thank you, Professor Shubir Dashgupta. Am I to begin now?
Yes, sir. Yes, sir. Yes.
Okay. Good afternoon, everyone. I am really thankful to you all, the organizers, Professor Dashgupta and his team, and all the faculty members of this renowned college, for giving me this opportunity to speak before you. I will begin from the very beginning. I understand that most of you are biologists, probably, and from other sciences. You will be using some softwares where you will use some which will be based on Python. So Python is the present craze, and it is the most happening language, computer language in the world now. So I will show you at the beginning. So how we can begin from the beginning. Okay. So I go to the present now mode. Okay. Your entire screen. Okay. I think I am now audible, and you can see the screen, right? I think you can see the screen, Right.
Still, it is not visible, sir.
Okay. Is now? I mean, you
No.
can see the you are presenting to everyone this.
Yes, yes, yes,
Okay,
yes,
okay.
yes, yes.
That means it's coming. Okay. So I said that I won't show you any PPT, but later I decided that I will show you at least three, four PPTs just to begin with, just to for warming up, and then I will go to the demonstration mode so that we can go step by step how we can install Python and how we can begin to type. Right. Okay. So uh, let's go to the PPT first. Yeah, here I am. Please tell me if sometimes I'm not audible or sometimes you want to stop me. Please stop me anytime. Of
Yes,
course,
sir. Make
yeah,
the slide, sir, in full screen.
yeah. I'm making it. I'm making it. So
Okay,
okay,
thank you. Thank you.
okay. So in this workshop, my part will be to introduce Python as a programming language. So basically, what is Python? Of course, Python is not a snake, but it is a name of a snake. Uh, well, Python basically is a computer programming language, like many other computer programming languages. You will know that there are very many different kinds of computer programming language. For example, 100 years old Fortran, then there are C, C++, C hash, then Java, then Haskell, then present day lots of other Ruby and all kinds of different kinds of computer programming languages. And some of the languages are useful for some purpose, and the other languages are useful for some other purpose. And in the scientific community, we mostly use Fortran, C, C++, and now this Python is very useful. And also, if you will know eventually that there are broadly two different kinds of computer programming language. One is called high-level language, and the another is low-level language. Low-level language is the language is close to machine language that machine understands, and the high-level language is closer to us, human language. So in between, there are many languages. If you program in low-level language, then the machine will understand fast and it will execute better, but human will not properly understand. It will be difficult for us. But if you write in very high level language, then the we'll understand very easily, like our written language, like English, or but the machine will machine will understand it in a slower way. So there is a compromise. So Python is towards higher side. We can say it is a high level language so that we can easily understand. And there are lots of other nice features, and basically that's why Python is useful. Python is very popular nowadays. Okay, so
Sir, sorry to interrupt. Sir,
Yeah.
sorry to interrupt you. Sir, can you move a little bit closer to your microphone?
Closer to my microphone. Okay.
Yes, a little bit
Yeah.
louder will. Yes.
It is okay. It is okay.
Yes, it is okay now. Thank you so much.
Okay,
Sorry,
okay,
sir,
okay.
for interrupting. Sorry, sir.
No. Tell me. Okay. So why Python? Because there are so many other computer languages. Why Python? Because I can list out a few of the features, because of course, it's a very powerful programming language and easy to learn. Anyone can learn this language in a day. Then, of course, which is the most important, is this data management by this language is very good compared to other languages, Fortran and C and other. C is, of course, low-level language, C++ even lower. But still, the data management is fantastic by Python, because you will see the life is full of data, and the whatever research you do, the ultimately at the end of the day, you have to handle lots of data. Particularly nowadays, you get lots of data from everywhere. Like if you are doing in physics, then in the CERN laboratory, then from the sky, then the astrophysics group, then the LIGO detector group. Then if you are working in say kind of stock market, every moment there are lots of data are coming. Even if you are working in biology and other things, you accumulate lots of huge number of data. And for other languages, it is not possible to manage the data the way Python can do. It's very efficient, very peaceful, and you will not, when you actually your put your hand in managing data, you will see how comfortable, how smooth it is to handle huge number of data so efficiently. Okay, so data management in short is good. And I can tell you that people say nowadays that there had been wars on oil for many years, still now going on the Gulf areas. Whole world is concentrating on the Gulf because of the oil. So oil actually leads the war and economy. So in the next generation and the coming years, many years, the war and everything will be, civilization will revolve around data. That you all know much better than me, because you will understand that. So that's why, because data management is now, data is available now because of social networking, because of other digital revolutions. So data is available, lots of data are available. We are waiting to handle the data to get some meaningful things out of it. So data management is very important, and that leads to another revolution, that is machine learning and the artificial intelligence. Machine learning, artificial intelligence had been there for a long time in the computer science syllabus in every university all over the world, but they were very slow, and they were not very, I mean, the future was bleak. But now, since data management has been possible with the computer programming like Python, so the system, the artificial intelligence and machine learning and deep learning, all these names you will hear, that's are now in the first gear. Okay, so data management is very good. And then there is a clean syntax. You will know that if you have to write a full-fledged computer program, sometimes it is very tedious, sometimes it is very kind of difficult to write, and even difficult to understand what other writes. So one thing is clean syntax. I mean, the syntax is minimal, and you have to follow a certain things so that everybody can understand, and so that the program or code or script, whatever we say, that is readable. So if you write something, others can easily understand. So that's why you can leave a program, and the next generation people can build on that. So it's a code readability. It's called code readability. And the another most important thing is this. This is open source. If you have handled computer programming, you know that Fortran and C and other programming languages, you have to buy the real compiler, which compiles your code into the machine language and then gives answer for you to understand, to be able to be understood by the processor. So the compilers are very you have to buy the compilers. It's not cheap. So, and the Python is the revolution, because Python is open source. Because open source means you can go to net, you can download any file, anything, any kind of app, whatever related to Python, and there are lots of people doing on Python, and so you can actually start using right now. And so this is open source. And the another important thing for open source is that you can also contribute. Suppose in your biology, you write something, certain code, which will be very useful for your biological work, and you prepare a code, and you can upload in some, there is GitHub, there are other sources are there in the internet, and so that other people can use. So there is a huge community that has grown surrounding this Python. So that's very important thing. You will never feel alone while you are doing Python. So it's a great community support. So the best thing is the Google. If you learn today a little bit of Python, if you have not used Python before, doesn't matter. Basic thing is that you keep some little things in your mind, and then you go to Google, search. There will be some community or the other. They will help you. Okay, and of course, Python's own documentation is there. There are lots of tutorials are there. There are lots of kinds of people. That's all free. Lots of communities, lot of, like your biology community, like your physics community, chemistry community. There are lots of geography community. They are really helpful, and the community support is important. Okay, and of course another thing you will soon understand, it is interpreter based language. Normally what you do in all other languages, we write a code. It's a long code, probably. Maybe it can be 10 lines to thousands of lines. And once you finish writing the code, like a long poem, then you try to compile this code in the through the compiler, and the compiler says you have gone somewhere wrong. Then gone. You have to again go to the code, and you can check where it can go wrong. It is called debugging. You have to debug the whole set of instructions, that is you call code, and then you will later you find, oh, there is a mistake, then again you run, again do. So that's a kind of hazard. But Python is interpreter based language. It works in the way other languages work, but still on top of it, you can write a particular line on the interpreter. I will show you what is interpreter. It's nothing but a command line, and you check whether this is working or not. So that is the way the Python goes. So these are the main features. There are many other features, of course, many other important things, attributes of Python. That's why Python is the most popular language in the world now. Okay, so there's a cartoon. So it says, you are flying how? So this guy says, by Python. So Python is so comfortable and so useful. And if you can read this, you read. It's not very important. Okay, so you can actually use Python in any, whatever you are working, whatever subject you have, doesn't matter. You can go on using Python, anything based on Python. Okay, so the preliminary knowledge, even if you are will be using PyMol kind of software, which may not at the instant, at the very primarily, may not be require you to learn in-depth Python. But of course, basic knowledge in Python will be useful. But of course, if you are doing biological modeling or something like that, mathematical, solving mathematical equations for biology or other kinds of things in chemistry, physics, everywhere, you of course have to have knowledge in Python. And the other important thing is that why it says you are flying, because when you will write programs in Python we call it script, or you can call it program, you can call it code, whatever. So when we are writing a script or code or whatever, often it will be used. But you see that the number of lines of the codes is not much. And the more importantly, whatever you will elaborately write the instructions following some algorithm, some logical statements and things like that, you will think that somebody has done for you. So only you have to know when and what you will use. Most of the time, your task will be easy. I will show some very trivial examples today to show you. I won't take you very deep, because one day it is not possible. But when you can yourself discover how Python is very kind of useful, and how you will like to do programming in Python. Okay, so this is of course a cartoon, and you know that before you appreciate the cartoon, I tell you that the Python was discovered by this guy, Guido van Rossum. He is from Netherlands. He's a computer physics guy. I think it's from the computer science. He wanted to write some code which will be very appreciated by the students. It will be useful, which will be very minimal, and etc. etc. So he started writing his project. So this project now has grown up, and now it is full-fledged Python. But after he finished the basic things, he started to think, what can be the name of the new computer programming language? So, but this guy likes the BBC television serial, which is called Monty Python. It's nothing to do with Python Snake. So he likes Monty Python Circus. So that's why he kept the name Python. But the computer and other communities now picked up the snake of Python. So that's why you will see everywhere there is a symbol of snake, but it is nothing to do with snake, of course. So that's why probably the snake, the Python is very kind of angry, eating everything and looking for Guido van Rossum. So that's it. Okay, so over to demonstration. Now we'll go for demonstration. Okay, you can ask me before even going to demonstration. You can ask me any question, if moderators allow you, and you can interrupt me anytime. I don't mind. Okay. So I go here. Okay. Okay. So I go to begin with. I suppose you are working on. Suppose you are working on Windows. You can work on any platform. So you go to www.python.org. This is the official site of Python. Okay, so this is the official site of Python. You can go here. It's a very nice this thing. Okay. Well, you go to about, then downloads, documentation, everything. If you want to download Python, go to download. But before that, I can show you that in the documentation part, you can learn it yourself. There are very the important thing to say about Python is that Python language is something that you can learn it by yourself. Of course, you don't need any help. So there is a beginner's guide. There are audiovisual talks, etc., etc. There are Python books, Python essays, and there will be plenty of documentations with every little thing. In Python, you will hear the name object. Everything in Python is called object. Object is a concept in computer science, but I will go into the details. But suppose some thing you write in Python, everything is an object. So I will often refer to as object. Okay, so to download on your laptop or desktop, you go to Python site, python.org, official site, go to downloads, and then you will hear that there are two versions of Python. Because when Python began its journey, it was being developed with certain kind of aspiration. Then after many years, it was being developed at the end of 1980s, 1990 onwards. Okay, so that old fashioned Python that is still existing now, that is called Python 2, version 2. And then the Python makers have now the ambition, it is much higher ambition, because it will want to understand everything under the sun. So it will actually include all the Unicode strings. What is Unicode? Suppose you are writing in Python and you want to, in the program, you want to include one Sanskrit slok or a Bengali poem. You can include that. It is becoming so versatile. It will become so versatile. So Python 3 is actually minding that thing. So Python 3 will be very, very powerful. But to begin with, you can work on anything. I will suggest, if your machine is old and the Windows is old and not updated much, you can work with Python 2. Anytime you can install and uninstall, no problem. At the user level, there is hardly any difference between Python 2 and Python 3. You won't feel much, only a few things I can tell you. But suppose you want to download Python 3. This is the latest version, Python 3.8.5. On your machine, you can click here and it will, the executable file will be sitting on your machine, and then you click done. But I will suggest don't do that at the beginning, but you can go to down here, view the full list of downloads here. And here you have all the versions, all the release date, etc., etc. But you go down here at the end, looking for a specific release. Yes, you can. This is the latest one, Python 3.8.5, and you go to here and download. Moment you click, it will another window will come. Of course, it will guide you. It will take you. Go down here. You go down here, And if you know that your machine is 64-bit machine, but most of the sometimes you never know that what is your machine, but most of the almost all the machines that you bought in recent times, in last few years, will be 64-bit machines. Earlier machines had been were in 32-bit processor machine. Now the processors are all 64-bit processors. So you go here and you see there are lots of files. You will find this Windows x86-64, which means for 64-bit web-based installer. You can go here. Okay. Not web-based, executable installer. You can go here also. You can go here also. So if you click that, see, you see the down here at the bottom, see the Python -3.8.5 AMD 64.exe file is being this is being downloaded. I don't want to download here. Okay, so it will be downloaded here in a moment. If your net is fast, it will be downloaded in a moment. So now if you just click it, okay, now if you just click it, sometimes you have to double click it, so the Python will open for you. So you'll see there will be an idle is, I'll show you. So if you go here, okay, or you go here in your these things, idle, you see the idle. So sorry, Python idle, idle means, I'll show you. IDLE is integrated development and learning environment. Nothing, just it will give you a platform, it will give you a window where you can start working. Okay, so you can take it on your screen, on the desktop screen. I have already done that. So here it is. If you can see it, my screen, idle Python 3.8 64. Okay, that's it. You click it. It's so easy. Okay, if you click it, so the window will appear. So this is your interpreter window. Okay, double open it. Okay. I will go here for demonstration purpose. I go to option. Let's see if I can increase the size. If I tell me if you can see it. Okay, I think you can see it. Please tell me whether you can see it clearly. Otherwise, I will increase the font size. Okay, you go to option. Configure. You can see it properly, or I can increase it.
It is visible.
It is visible. Okay, so this is these three arrows. These three arrows are the, it is called interpreter. Okay, so the window is called this window is called, you can increase this, decrease it, no problem. You can whatever you want to do. Okay, so this is your interpreter window, or you can tell it this is an idle. Idle means I can tell you, I told you this is integrated development and learning environment. Okay, so basically this is a command line. Well, so you can type it here. So if you write, so your first program, so it's a customary that if you begin any program, you'll type something called the hello world. Also write print. So that is print, print, and you have to give a bracket, and then you write some, whatever you write in inverted comma, say hello world. Hello world. If you write that, it gives you hello world. Okay. So if you on the interpreter, if you don't have to write even print, if you write say hello world, anything you write, hello Python, say hello Python. So you write in with two inverted commas. Single quote, double quote, doesn't matter. It will show you hello Python. Okay. So this is the first. You begin to type now. Okay. Anything you want to print, if you are typing on interpreter, you can just write it. But if you write say number, say 2, it will give you 2. If you write say 4, it will write you 4. But if you write say 2 plus 4, it will give 6. That means you can already understand this Python interpreter now works as a calculator. If you write anything, say some number multiplied by any number, So this is the star. The star is a multiplication, right? I can make it bigger. I can make it even bigger. I can make it say bigger. Okay. Okay. So okay. So you see the some number. Then you write star. Star means product, and this another number, and it will if you enter, so it will give you the number. So okay. So understand that your Python interpreter is basically a it's a calculator. It can work like a calculator. Okay. So some sound is coming. Probably somebody's video is on. Some audio. I think audio is on. I think. Okay. Okay. So so I mean, before beginning any to write any program, we must appreciate that the program is written by there are few ingredients. That means you write anything, you need some numbers because ultimately you calculate something, or you give some instructions. That means through something, some symbols. That means you need some symbols. So symbols and numbers. So you know the in Python or in any other language, if you write the numbers, it will take the numbers. But if you write the alphabetic something, some text, so text you have to write between two inverted commas. Like I wrote here, hello Python or hello world, right? So this is called string. Anything you write is a string. Like if I write say Abhijit, it will give you error because Abhijit is not defined. It is not understanding what it is. But if I write say quote unquote Abhijit, so it will work. It will understand this is a string. You see, if I write, there is a type. There are lots of things in to check what it is basically. Suppose there is a built-in function called function. You know something. I mean, if you have used many functions in your function in your science, particularly in mathematical based science. Function is something you write some function, some f of some x, sorry, f of x equal to say x, so 2 plus x, etc., etc. So this is function. That means see, you give some value of x in preliminary mathematics. We have done that. You give some value, say x equal to 3, then 2 plus 3 will be 5. If you give x equal to 6, it will be 6 plus 2 equal to 8, and so on. So this is function. Functions means we will understand that any name, some name, it doesn't have to be necessarily f. It can be anything. Any name followed by some two first brackets, means parenthesis. And inside what you write is an argument. So this you will understand. Okay. So like here is a function called type. Type is the name of the function. Inside that, I write something, say 3. Let's see what it does. Type is a function. It is built inside this Python, right? So, so this type will tell you what is this object 3. Okay, let's see. So it is saying that it is a class. You don't have to understand the meaning of class now, but you should understand this. This is int, integer. Suppose if you write say type say 3.78, it will write you as a float. Float means some fractional number. What we call fractional number in our mathematics, that is in computer science language, it is called float. Okay, float, or sometimes in some language it is called real number, real. Okay, then there are so these are integer and float. You will understand that whatever you do in Python or in any other computer language, you have to understand the numbers. So numbers you already know, but you have to know how computer knows. So in here you see that this is the integer. Suppose you write type of something, anything, some huge, sorry, so some huge any number, any name. So it will understand it's an integer, and this is of course float. Then of course in mathematics you have complex number also. Complex number means you know the root over of -1 is something you cannot decide what it is. So it is an imaginary number. So I, it's called I. In computer, it's called J. Suppose you write 2 plus say 3j. That means the real part is 2 and the imaginary part given by j, and so its prefix is 3. That means the j signifies that it's an imaginary number part, but the number is 3. That means imaginary part it is 3 and the real part it is 2. So it is the complex number. So if you write what is type, inside that if you write 2 plus 3j, j is basically, you have to understand in Python language, j is basically square root of -1, right? So that j square is -1. So it's a square root of a negative number. So see, it has told you that it is a complex. So that means, remember the function type. Type will tell you what type of thing it is. Also, you have you can these are all numbers. Then suppose, well, you do algebra since class 7 or 8. So you know we'll begin to write the numbers and we give them some name, x, y, z, or whatever name you have, because then our mathematics becomes a very general type of mathematics. We can do all kinds of addition, subtraction, multiplication, and division, and all kinds of taking power and everything in terms of symbols. So the mathematical operations with symbols is algebra, nothing else, nothing kind of extraordinary thing. So what the arithmetic operations you have done, and then students do algebra. So we give some names, say common names, x. So we give it x equal to 2, say. Well, so you see, type, if you write x, it is integer. Okay. Before I go, okay, let me go. So x equal to, you write x equal to 2. Suppose you write y equal to, say, 5. Okay. That means in computer language that you have a number 2 and you gave it the name x. That means it will be stored in the computer memory in the name of x. See, I have given the name x. That means it is an assignment. In computer language, it's an assignment. It is not exactly an equation or something like that. It is assignment. The number 2 is assigned as 2. Suppose now I call what is x. On the interpreter, I don't have to write print. Okay. When we write full-fledged program or code or script, I'll show you. Then I will write everything in with print and things like that. On the interpreter, if I type x, so see, it will show you x. The value is, the answer is here. If we type here y, it will show you this 5. Suppose I now write x equal to, say, 4. Suppose now x equal to 4. Now it won't show x equal to 2. Earlier it was x equal to 2, but now I reassign the number 4 to x. That means that name x I gave to the number 2. Now I take out the name and you put the tag on 4. Now the number 2 is gone. Okay, so now x is 4 and now y is 5. Okay, you can see ID, identity, where it is stored. ID of x, you can see it. It will show you some number. You don't have to do anything with this number, but it tells you that it is some memory address where it is stored. That means you can be assured the number is stored. Anytime you call x, anytime you call x, it will show you the number. Anytime you call, you can call want to check what is the ID of y. Okay, so this is another ID number. So that way you can be assured that the numbers are stored in the memory location. But the moment you go out of this window, these things are gone. Okay. Anyway, so suppose now you begin your program. So you write x equal to, say, I write it again, 4. This is one instruction. You give it to the computer. This is one instruction, one line. Y equal to, say, 5. This is another instruction, another line. Now you write, say, another name, give another name. So z equal to, say, x, and say plus, and then y. That means the value, the assignment in x and assignment in y they are mathematically added, and the addition is named as Z. Now, if you write Z, so Z is 9. If you want to write through print statement, print Z, so it is see it is 9. So this if you have never done computer programming, you can assume that this is your first computer programming drive. So this is the first computer program in Python program you have now written. Okay, so this is on interpreter. Now you can suppose this is a valuable program, you want to store it for your future reference. Moment we go out of here, from here, it will be vanished. We can open again, and now I see X. It doesn't show because it's gone with the window. It is actually cleared out. So again, I write say X comma Y equal to 4 comma 5. Well, you can write in one line also. So in Python, it will give you facilitate you to write in this way. The first variable, the first number, actually it counts from the right side. So on the first right side, the first number 4 is assigned as X, and the 5 is assigned as Y. So you see X is 4, Y is 5 again, and Z equal to say X. So this time I multiply X times Y. So Z is this 20. Now, suppose you write this program in a file. That means it will be a computer script. So go to file here. Here is on the leftmost here. You may not be able to see in your machine because it is so small. You create a new file. Okay. If you write here X comma Y equal to say 4 comma 5, then Z equal to say X star Y, etc., and then here it is not an interpreter, so you have to write a print statement so that it gives you print. So print, and then inside you write Z, because see the print is a name, some name, and it's followed by this parenthesis. See this parenthesis, first package. So that means print is also a function here, like type, like ID. Print is a function. So this is your computer program. This is your first program written in a file. So you can write on the top what program it is. You can write say this is my first program, etc., etc. But this line is not a computer instruction, so the compiler will be confused. So you put a hash symbol before that. See, the color is changed. That means this is a headline. The computer compiler will not mind it. It will not execute it. So this is, you can decorate anything, any line. You can write any line, and before that you put a hash symbol, so that it is for documentation purpose. Also, you can write with inverted commas, and can write I am enjoying this workshop, etc., whatever, something you write, say, etc., etc. That means it is also a way you can write multiple lines, or I am bored, or whatever, or something. So whatever, multiple, this way you can also write multiple lines. You'll see it is very important, because you will work with many imported Python-based compilers, and when you go to see inside it, the first thing you will encounter that something is written between 3 inverted quotes. That means it's called commenting. That means the block comment. This is called line comment. One line is commented. That means Python compiler will not mind it. And this is some more lines. You can write something, anything, whatever comes to you. What happens? Okay, okay, okay. Something, some whatever comes to your mind, you write. But inside 2 sets of 3 triple quotes. That means,
sir, your screen is not visible.
Your screen is not visible.
No,
okay.
no.
Okay. Let me go again.
Present now.
Okay, let me. I think I by mistake. I by mistake. Present now. Entire screen. I'm sorry. I'm sorry. Share. Right. Now it's visible. I think. Now it's visible. Abhishek.
Yes,
Come in,
yes,
sir.
yes, it is
Okay,
visible.
okay. Please tell me, interrupt me. Okay, so now this is my program. Okay, so this is a block comment. I can write anything. So you will use any imported program later on. So this will be called modules in the language of Python, or package, or you can call it software. But in Python computer language, we call it module or package because it has certain ways of writing things. So the first thing you will encounter is that these block comments. Okay. So now this is my program only. These 3 lines. Okay. So now it is in the file. I have to give it some name of a file. I can run it. Here it is run. Run means it will actually execute in the computer language, machine language, and then it will give me the answer. So run it. So run module. And before run it, I have to give it some name. So generally for the testing purpose, I give some name. It's a test. You can give anything, any name. And you will see the names will be automatically, whether you give some extension or not, the names will be .py. See, I don't know whether you are able to see it or not. test.py. Py means Python. If you write a program in Fortran, it will be something .4 or something .f. If you write it in C, it will be something .c and so on. Okay, so I write it test.py. Since the file already exists, I actually worked on this with this same name. Okay, I overwrite and I write yes. And you see it is on another window. I'll show you two windows. This is one window where actually I am actually compiling the program in the name. This is the program or code or Python script, and this is the interpreter window where from we came. Here is the file, etc., and the answer is given here. You see, answer is given here. The answer is 20. So this is the first program now you have written. Okay, so now we will carry on. So okay. And the another thing is that I was writing a string. So I'll show you some type. I'll write to type and put something inverted commas. Say I write my name with inverted commas. You see, it is showing you this is a string. str means string. So we'll understand more. You go into the detail in the Python programming, you will understand that there are very many different kinds of objects. String is an object. Say integer is an object. Int integer is an object. Float is an object. Every little thing in Python is an object. So they will call it class. Class means it's a blueprint of an object. You don't have to understand everything, but here the name class and object, they are synonymous. Okay, from class you prepare one object. Class is the fundamental, and then therefrom you derive all the examples. That examples are objects. Anyway, so you remember certain things when you are doing in Python. You will see that you have certain built-in functions like this type, this ID, etc. I'll show you lots of other things which will enable you to tell what are the things, what you will do, etc. Okay, so you go on knowing everything. You will go on now doing. You will now do Python programming. Okay, so in any programming, okay, any programming, not in Python, Fortran, C, they have now the syntaxes, a particular kind of writing the instructions. What I have written is not even in the depth of Python. It is very preliminary. When you actually do hardcore programming, but I believe most often you do not have to do any hardcore programming in Python, because lots of functions and lots of modules will help you, you will ease your task. That's what I can tell you. But At least for the time being, uh, even if it is board, you can at least I can tell you a demo. I can give you some demonstration to tell you that there are very basic things. Like suppose you are actually summing up something, some numbers, for example. Suppose you are writing, say, 2 plus 3 plus 5 plus etc. etc. plus 6 or something. So you have, suppose you sum hundreds of numbers, thousands of numbers. It is not useful. It is not good. I mean that you write all the numbers plus 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 plus. Suppose the numbers are stored in a file or in somewhere, and so you just want to have a sum at one go. So one thing is that you can do is that means you are actually summing up, that means adding up. That means you have to add 2 plus 3 equal to 5. Then 5 plus 5 is 10. Then 10 plus 6 is 16. So that's why you have got this sum. So this thing is done by a loop. So that means you do things in a loop. Okay, I'll tell you that. Okay, suppose you write a loop. That means you do the same summing operation. It's a summing operation. You are adding this. Okay, mathematical summing operation. So do it again and again and again for hundreds of numbers. You give the numbers from outside, and it will actually add up. So suppose you write, say, for example, say x equal to, say, 0. Because you see the logic, before you come here, you have initially hate chilo shunno. That means you had 0 at hand. So 0 plus 2 is 2. The same logic will appear. Then 2 plus 3 equal to 5 and so on. Suppose you write x equal to 0. X is some name. Okay. Now you start a loop. Suppose you write for, and you write some index, name of some index, something, whatever, doesn't matter. Say I in some numbers. It gives them 2, 3, 5, 6, 9, 11, 15, 16, whatever. Okay. That means you want to sum all these numbers. Okay. I write them in two first brackets. Why I write, I'll tell you. And I doesn't, never mind about I or whatever some name you give. This is a dummy index. For is you see the orange color, for and in, they are Python commands. So that's why you have to write it must. You begin with for, I mean loop, you are looping it. What for you looping it? You are looping it for this thing. That's what, it begins with for. Okay, for some dummy index I in this, that means I will take these, and so on, and you end this up to this part, and so you have to separate the next part with a colon, as if you are writing a compound sentence. So this is your syntax. If you can remember, actually when you go on doing this repeatedly, you will remember this. So this is syntax. For every language you have to do this. For I in 2, 3, 5, 6, 9, these numbers, put into brackets, first brackets, and then colon, and then you enter. I'm writing it on interpreter. You can write it on file also. Okay. You see, the interpreter automatically does not go here. The interpreter automatically goes inside. That means it is in Python language. It's called indentation. That means it is actually stopping a little bit inside. It can be, you cannot start from here. You have to go little bit inside. 1 step, 2 step, 3 step, any step. Okay. So it is measured here in this interpreter. It is designed. The cursor will be here. Okay. Now, if you write, say, x equal to x plus I, what does it mean? I will dummy index. It takes first number 2, first one. Then the value of I should come inside this. I is 2. Then 2 plus 0. X is 0 already. So 2 plus 0 is 2. So the new x is, it is reassigned. So right side is old thing, and the left side is the new thing. So it is not an equation. It's an assignment. Okay. Otherwise it will be x would cancel out. Okay. So this is actually, you are summing up. So next instant I takes 3, then it takes 3, value of I is 3, then 3 plus, now x is 2, 3 plus 2, and the new value of x is 5. Another instant I is 5, 5 plus, then old x is 5, 5 plus 5 is 10, and the new x is 10. Done. You can now enter this, first enter. It is expecting that you can write something else. I don't want anything else. I want just to sum this. Done. The sum is done. Now, if I write x, I don't even have to write print on the interpreter. If I write x, the x is 52. You see, 2 plus 3 plus 5 plus 6 plus 9 plus 11 plus 16. All the sum is done, and the sum is now 52. So this is a loop. This loop is very common. Suppose you encounter any program in Python, some program or the other, you will find out this for loop. And I can tell you this for loop is common in C language, C++, wherever. In Fortran language, this for loop is called do loop. It starts with do in Fortran, but it has taken syntax from C, so it is starting from for. So for means you have to write this structure. For, then you give some name. Name doesn't matter. IN, any name, anything. And then in where? In this this collection of numbers. See, this collection of numbers, it has a name. It has a name. In general, whatever you write, it has some pieces in it, right? One is something. This piece, 1, 2, 3, 4, 5, 6, 7, 8. Some pieces are there. It's not a pure number. It's a collection of numbers. So this collection is in the language of computer. It is called iterable. Iterable means something you can iterate over. This is basically an iteration. You are iterate over some in a loop. Okay. And the particular structure is followed by these two sides on the first brackets. This particular iterable has some name. It is called tuple. T-U-P-L-E. It's called tuple. T-U-P-L-E. So tuple is a kind of object. Okay. So you will get to see it later. Okay. So that is a way you can with writing a code. This is piece of code you're writing. You can write it in a file, and you find out the sum of some numbers, for example. Okay, but you don't have to even do that often. Your task in Python is even easier. In other language it is difficult, but in Python, suppose I write, say for example, I give it a name. Suppose I give it a name, say S. S equal to, I write 2, 3, 5, 6, 9, 11, 16. I write these numbers, right? And I give it a name. So the name I give, that means this is the iterable I have written. This iterable here I have written separately. Suppose you are supplied with these numbers. I write separated by comma. That is important. You have to give some comma. These gaps are not important. Comma is important. And is surrounded by two first brackets. And give it a name S. Now you see what's S. Type S, right? You type S. This is called tuple. This is tuple, right? So now, and if you write, say, I give it some other name. I can give any name. Say A equal to, I can write, say, say, I write, call it. I give it this bracket. This bracket. It's a square bracket. Now I can give it some other name. It doesn't matter. You give the same name. So now you type what is A. Numbers are same. Everything is same. Only brackets change. That is A. So it is a list. So it is another kind of object. So basically, there are two different things, but are the same thing. Why? Because these are two different objects which have two different kinds of powers. But basically, they are two iterables, and more importantly, they are two collections of numbers. That means you can collect any kind of numbers, any number, any set of numbers, and put it in some brackets, either square bracket or you call third bracket or first bracket, and sometimes we call it, it is called it tuples, and other time it is called it list. Okay, so now you will find the same thing, these 3 lines I had written here can be done in a moment, because on the list and on the tuple, there are some functions, particular functions that will be applied here. I'll tell you how you can remember this, how you can get it. I'll tell you, but before that, I can just give you some demonstration. They are called, these particular functions are called methods. Methods. Remember the name method. So the one method is, I want to sum these numbers, right? I just write the sum, S-U-M. The color. The color is violet. Color is violet means it is a system function, right? And inside that function means anything is followed by bracket, first bracket. Inside that you write S. That's it. Done. So you see, your effort is this hard work, this writing in the loop, etc. You don't have to do that. You are actually writing sum. You first declare it as a tuple, and then you write sum of S. I've got number. If you write the sum, SUM, and then write A, also it will get the same thing. So the sum method works on tuple, sum method works on list. Okay, how do you know that? Okay, so suppose if you are, suppose I begin from the beginning again. Then you will understand. Okay, I can begin from the beginning again, intentionally. Okay, I can go on. Yeah, when it's coming. Okay. Oh, I can even remove this. I want to open freshly. Why it is coming? Wow. Okay. So suppose this is the first time you are opening the interpreter. The first thing you can do is that you can write dir directly. What is there inside? If you write this dir, it will show you something. So these names, don't mind. They are some. This is underscore built-ins underscore. Suppose you write dir underscore double underscore, right? Built-ins. That means basically some built-in objects and functions will be there. Underscore. Yeah. It will show you lots of names. That means it is showing you some directory. You can see the name sum. The sum function is here. You can see the name str, string. You can see the name tuple. All these functions are, you can see the name type. Type. So far we have used. Lots of things are there. Whatever you want to use, you can use. Okay. So these are the things that is already there in the built-in directory. This built-in directory. This is a built-in directory. Now you want to see how this sum works. What is this sum is going to do? That means the manual is there in online. That's what people say. You write help. You remember 2 keywords. One is directory, dir, and you write the name of some directory. Here the name of the directory is written in some peculiar fashion. Underscore built-ins. Rest of the thing doesn't matter here. Only this thing. If you write help, and then suppose you want to see what is this sum does. SUM. Okay. Let's see. It will give you help on built-in function sum in module built-ins. These built-ins, what I called is a directory. The directory, it is in the language of Python, it's called module. Okay, it's a module. Okay, it doesn't matter. See the sum, how it works. Inside the sum, you can read it. Inside this bracket, here first thing is some iterable. Iterable means something like the list or tuple, and there are so many others. I won't go into detail. And it will write you something here. So for anything, Suppose you want to write, say, tuple, or you want to write, suppose you want to write, say, uh, say help, and inside this tuple, you see what is tuple. It will show you in these Python 3, it is squeezed. That means the lots of lines are there, so it's squeezed. So double click it, and it will show you help on class tuple. So tuple is basically it looks like a function, but it's an object. It's a class. It's a class. It doesn't matter. So it will show you lots of things inside. If it is, sometimes it will give you some examples. Even if you cannot understand here, you go to Google and search how tuple works. Here, lots of things are there. You can read it in time, and you some of the things you can understand, some of these things you may not be able to understand, but it's not necessary. Some, if you are very keen in computer programming, and then you can of course discover yourself. Okay, otherwise Google is the pure help. Okay, so tuple and the list are the two sets of two kinds of iterables which deals with the collection of numbers. Okay, and suppose I write some list x equal to, I can write a list like I write say 2, 5. Then I can also write a string a b c something. Then write something, some another thing. Then I can write some 1, 2, 3, etc., etc. See, what is this? All the items you know, right? 2 is an integer, comma, then 5 is an integer. Then whatever I have written, but I have given 2 inverted commas. So it's a string. It is a number, but I put 2 inverted commas, 2 sides. So it's also a string. And this is a list. Okay. So, but whatever inside there is, doesn't matter. The whole items, the number of items, 1 item, 2 item, 3, 4, 5, etc. All the items are surrounded by 2 square brackets. Okay. So that means we have 1, 2, 3, 4, 5 items. And inside the 5th item, we have another 3 items. It doesn't matter. It is a list again. It's a complicated list, but it is a list. So type X, the list. Okay. Now, if you you can actually, if you go on in detail, I don't know how much time I'll get. I'm still at the very beginning still, but I'll show you plot also. Okay. Okay. So the list, basically the members, actually in Python, everything you want to count how many members are there, right? So suppose I can write, there is a function called function, or it is in terms of Python for applying to list, it will be called a method. You see, some specific functions applicable for list, tuple, etc. objects are called methods. So I use another method. I used the method sum, but of course I cannot sum it here. If I write sum of x, of course, it can't give me anything because all are inhomogeneous objects. This is string, it cannot sum it. Sum can be done only on numbers. So it is giving me unsupported operand type, etc., etc. It is giving me some error. But if you write another method, right? Len means length of the object, total object x. You see, the len is 5. That means 1, 2, 3, 4, 4, and then it is 5. Okay, so it's a 5 objects. So suppose you are dealing with some numbers, right? And you have got some collected some data, huge number of data, and the data is you have written in a file. I'll later show you, or maybe you will discover how a data written in a file can be converted in a list automatically. And then once you have list, you will begin to apply the methods on it to know all the aspects. Suppose you have a new thing, some list, and you want to know how many numbers are there. That means how many data points are there. What data points are where, what is the maximum value, what is the minimum value. To know everything, you are supposed to write a program. But I can guarantee you, you don't have to write a program. For everything, there is a method, there is something that you can work on. I mean, it's just one line thing. I mean, you are actually writing a program, but at the end of the day, you will feel that you have done nothing. I mean, just writing some commands. That's it. Some function, some method, something like that. You don't have to write a complicated write through some complicated algorithms, some for loop, etc., etc. Most often, you don't have to write. Okay, but it is better to know, because sometimes it is necessary to use the for loop. Then I will come to the logical loop. If it is not, I mean, if you are bored, I won't go into that. Okay, so len of this. And now you can know which element is where. In Python, actually, the counting starts from 0. You always remember that. It is like the elevator style. Some say it is a ground level, some say it is a level 1. It's American and British style. So in Python, it follows from 0. It is a 0th element. That means 0, 1, 2, 3, 4. That means total element 5. But the numbering will be from left to right, it will be 0. Okay, now see x. I want to know what is the position member at the 0th position. Then you have to write a square bracket. X square bracket, and then you put 0. So number 2. Now if you write x1, it will be 5. X2, it will be 2. Then x4, it will be this. Then I can write x5. Of course, it is not there, so it will give me show me the this thing. Show me the error. You see the x4. X4 is again a list. You see, if you write type and then x and then 4, you can rename it. You can give it some other name. You see, this is another list. Okay, if you write say x4 is this, you can write some another name. Say y equal to x4. If you are not liking to write x4 again and again, you write y. So you type y. You write type y. Now, if you write y 0 in the same fashion, it gives you 1. If you write y 1, it will give you the same way. If you write y 2, it will give same fashion. If you write len of y, of course, it will write this. Of course, you could write len of x of 4 of this, right? So it will give you the same thing. So that means you see that you learn these techniques, how to apply the methods, basic methods, len, sum. There are very many methods, of course. Okay, so you see how you know what are the other methods are there. Okay, so there are methods. Suppose you can write help. You can type help, and then you can write list. You see the list is there. You can see the help. You can read these. You can lots of things that will be here. You can see this. But if you write the help, or you write dir, methods are all built-in methods. Already it is there. Okay. So and if you write say underscore built-ins underscore. You see the len. You can see the len. What is the len? KLMN. Len. Here is the len. Here is a len. There are other things. List is there. So len is a function, or we call it as a method, which is being applied on list, tuple, etc. Then there are dictionary called. It is called. Then there are set and all that. I'm not going into everything. Okay. So these are the things. Okay. So basically list and tuple and all this collection of numbers, you can handle it so easily as if you don't have to write a program. You can get some basic information of data. You can actually create a lots of data. Suppose for your analysis or for your something, some building up some models or something like that, you want to create some data. So there are actually methods. There are actually functions, not methods. There are functions. Methods or functions are the same, but methods are these special functions. Okay, there are functions called, it is here, I think it is here, this is called range, right? See the name of the function, range, this range. Huh? So, okay. So this is range. This is range. So range is a function, for example. It will create a range of integers. Suppose you create range to write, say, 10. You see what it does. It actually creates range of numbers from 0 to 10. In Python 3, I'm using Python 3. In Python 2, it will automatically show you the numbers, but I can convert it in a list. So I can write list. Of course, I told you that list is a function. So inside that, if I write some numbers are now in the range like this, right? So I can write range the 10, right? Now you see, it creates the numbers 0, 1, 2, 3, 4. Because in Python, if you don't say anything, it will create always from 0. It will count always from 0. Okay. By the way, there is another thing. Suppose this is a list, right? You can check what it is. So type and put inside the type. So type of list of range. That means you first create a range of numbers, then you convert it as a list. Of course, it is a list, and you can again make doubly sure what is the type. Of course, it's a list. Of course, it is a list. So suppose you give it a name. Give it a name. Okay. So X is your list. So type it X. So suppose X, of course, 0 is 0, 0th number. X, 1 is 1. Of course, 1th position, but the number is 1. Suppose the numbers are counted from 0, 1, 2, 3, 4, 5, 6. Rather, I created different sets of numbers so that it may not be confused. You may not be confused. So I can create a range. If I write 10, it will create number from, see, it counts from 0. Of course, one thing you have to remember that it will go on step by default step 1, 0, 1, 2, 3. And of course, it won't touch the number, final number 10. It is the stop. Before it will stop. So it will go up to 9. If I write range, say 11, then of course it will go to, sorry, if we write X equal to list of range of 11, then of course the number will go up to 10, of course. Yeah. Now, if I write, say 2 to 11, right? See what it does. So it goes from 2. So it starts from 2. You have dictated it. It starts from 2. And it won't touch 11, of course. It will go up to 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. But now if you write, say 2, 11, 2, that means you start from 2. It goes up to 11, but doesn't touch 11. And the step size is 2. You see the numbers? See the numbers? 2, 4, 6, 8, 10, right? So that way you can create any sets of numbers, any sets of integers, okay? Any sets of integers. Suppose you create a huge list. Suppose you create some 2 to, say, something huge number. And all the even numbers between 10 lakhs up to 10 lakhs, okay? It's numbers. So if you write this X, of course, it will take lots of time because it's a huge set of numbers. Okay, you need not see it, okay, because my machine is becoming slow now. Okay, it will take lots of time because it's a huge number. It's a huge number. It will actually plug my space. I should not do that. I should not do that. I should kill it. Okay, I should kill it. Okay. I should kill it. I don't want to see it. See 69,210 lines, etc., etc. But I don't want to see it. But suppose these numbers, you believe that this is a huge list, and I want to sum these numbers at once. But the sum will be done very efficiently. If I write sum of X, you see fraction of second. So it does the sum. I can write a small list, of course. I can write, say, list of range of, I can write, say 100 and 2 and then -1. But what it will do, it is not possible to interact, but you can understand easily that it will start from 2. It won't touch 2, but it is, a difference will be 1 minus 1. That means 199. You see the list. Now you can see the list. So a small list. So the list is this: 100, 99, 98, and so on. It will go up to 3. It won't touch these 2, right? If you see how many numbers, the lane of x, of course, it will show you. It will say how many sum of x, of course, etc. Then there are lots of other things there. I'm not going at the moment here. Okay, so the list and the tuple, and I'm not showing the examples for tuple, but remember one thing: the numbers. I mean, what is the position of a number? Say, for example, if I write x position of 0. Of course, it is 100. But if I write position, what I wanted to tell you, right? I count the numbers 0, 1, 2, 3, and so on from the left to right. And also, I can count actually from the right to left. So the rightmost number will be -1. Why? Because you can imagine this is a number line. This is starting from 0, 1, 2, increasing side. And this is the end. And the end, if you think it is a ribbon, it's a long line of numbers. And this ribbon can be rotated and can be put here. So the left number from before 100 will be, 0th number is -1. Then -1, -2, -3, and so on. So that's why the numbering system, this is -1, this is -2, etc., etc. So that, remember this is useful. I have given a problem on that also. So the counting of the numbers, if you can write, start from 0 to end, and you can start from end to 0, right? The end number is -1. This is -1, this is -2, right? You see the -1, x of -1. You see, this is -3. If you write x of, say, -2, so a number before that, so it is 4, right? So this thing. So this is the thing. Okay. So so basically that means this is what I am doing is now, in technical term, this is called indexing. That means you have indexed the numbers. That means you have given the positions of the numbers, and you are calling the numbers, elements of the list by the index positions. So it's called indexing. It is called indexing. Similarly, suppose you have the list here. You have the list here. So you can also slice. You don't want the entire list. Suppose you have a set of data, and this data you have collected, and you don't want to use all this data. Suppose you want to discard the first 2 data. You don't like 100 and 99. You want to start from here, and you want to stop, say, here, 4. So you start from 98, and this much data you want to take. You want to discard the last data. You want to discard the first 2 data. That's called slicing, as if like taking a slice of a cake. So slicing is going by indexing. Suppose this is 0, this is 1. So you start from, say, 2. You start from 2, right? So this is your 2. And you go up to the one before end. So if you write, say, suppose in the range you have seen, right? You have range you've seen. If you give the last number, it won't touch here. So suppose if I write, you have to the syntax is colon. That means 2. After that, this is slicing. If you write -1, that means it will start from 2, and it will go forward, and it will go up to -1, but it won't touch the -1. Okay, so it will stop here. So if you now see this, you see these numbers 98 and up to 4. So if you write, say, if you even want to discard this data, okay, fine. If you want to write -2, that means this is -2 position, the previous list, right? So you see the list has not, original list has not changed. This is the sliced one. The original list is here. This is the original list. So now if you write x 2 and colon, then -2, of course it will come from 98. It will come from 98 to -5, right? Yeah. So now you can also want that I don't want all the data in this range. I want to go by one step. I mean, I want to skip the in-between data. So in all the odd numbers, I can 97, 95 alternative. I want to take alternate data. Okay, fine. So that means if you write these, and if you write colon, of course, if you would write colon 1, it would give the same. That means basically the syntax is this is a starting point, then you put a colon, then you give the end point, but you don't touch the end point, and this is the step size. That means the step size is by default, I didn't give anything here. That means by default it is 1. And here you have given 1. That is the same thing. But if you write, okay, fine, -2, and then write say 2, that means it will jump one step, right? Okay, so you see 98, 96, 94, 92, and so on. Now suppose you have this data, and you want to suppose take this sliced data. You can rename this into some other name, of course, because the original X list is unchanged. Okay, now you can say, okay, now I can now sum of this, do some of this. Okay, I can take it here, and I can then sum. I can then do this data, and this is sum of this data. So this is something very important thing I've told you, that you are dealing with numbers, lots of numbers, and the numbers are coming from somewhere. You have collected from some your experiment or from your field work or whatever. And once you have got the data, be it in a file or so, if you are working on Python interpreter, it is easy for you, because I'll tell you how the data, even if not today, I'll tell you other day, or I'll send you the files. See, you can convert the file into a data file into a list. That because list, if you have a list like this, and you can handle the list very easily, you can get to know, you can slice the numbers, you can index it, you can get to know how many data are there, how many data points are there, you can sum it, you can do it, lots of things. Okay, so you can do lots of programming on list and tuple and all that, but it will be easier if I go a little bit in a different level, which will be easier for you to understand for the beginners. So I will import actually basically a module, and I'll show you that your life will be even more easier. Okay, so all the thing you will do basically is that once your model is done, once your programming, your experiment and data collection are done, all the things remains for you is that you are handling data. So basically, I will urge you to understand that what Python is powerful in. Python is powerful in handling data. So the numbers are being created in the moment. So lots of numbers are being created. Suppose you have created this X data. You want to take 10 multiples of data. So X just 10 multiples with this list size will be 10 times. Repeat. So if you multiply 10, so it will be like that. So it will be huge. All these data, 99 to 2, 100 to 93, and then again repeat. This is, and all the methods, all these attributes and whatever I am telling you, this will be, you will later know that it will be Same for string, same for tuple and all that. I can give an example. Suppose you write a string, x equal to, say, I write it, say, Hare Krishna. Take it otherwise, just fun. Hare Rama. Okay, so this is a string. Suppose this is a string. So this is, if you write for I, and the string is basically you write, type like a tuple, like a list. String is also iterable. Like you see, this is a string. If you write for I in X, earlier we wrote here in the for loop, earlier we wrote here the tuple, write numbers, but I now write X because X is now my string. And the inside the string, this is basically an iterable. Iterable means you have lots of pieces. All this in this string, this is one element, this is one other element, this is one element, this is one element, and even the gap is also one element. And then again another element, another element, another element. Whatever you write inside two inverted commas. If you write a hyphen, then hyphen will be one element. If you write a number here inside, it will be one element. Suppose for I in X, if I write print I, that means I want to I in some dummy index, and I is taking element one by one from X, and I want to print this, right? So see, if I enter, so it writes me one by one, H, then A, then R, then E, etc., etc. It is writing everything for me. Okay, so now X is this, and say if I write, so this whatever I've shown you for the list, I'll show you for the string also, because both are of a similar nature. What is a similar nature? Because both are iterables. That means iterable means it has pieces in it. So if I write X into, say, 100, that means the string I am multiplying by 100. That means this string will repeat. You see? It's a namavali. It's lots of these. It's the same thing as repeat. Hare Krishna, Hare Rama, and so on. So you can apply this thing to string, to tuple, to these things. You will slowly and eventually you will know that some methods and some things will be useful for your calculations. Okay. So now see, when I first began, I began with nothing. I have used whatever here. So this is the space where I am working. Is called namespace. That means I'm not going into detail in that, but it's called namespace. Forget the names. Just here once and then forget. So the namespace is nothing. Whatever I have incorporated. I have not incorporated anything from the outside, but I need to do that because for writing good programs, for writing efficient things, and for writing production quality works, I have to use, like you will be using tomorrow, PyMol and things like that. You have to import that module on your place. If they show it in a different way, that is something else. But you can actually import any module, anything here. So basically, what is a module? See, you have already encountered the name module or directory, because you see you have seen that. No? You have seen this directory. This built-in is a module. Then there will be, and then you will see the name package also. I'm not going into detail in that. Okay. So remember the name module or dictionary or say gallery or say library. So these are built-ins. The name suggests that it's built-ins means already it is here. You don't have to import. But for the basic Python itself, there are other modules for your purpose. You can actually import them here for your purpose. I will show you one module. Suppose if you don't mind using little mathematics, you have used certain mathematical functions, say sine x, cosine x, trigonometric function, then exponential, then logarithm, and all kinds of functions. And how do you know how they work? They are already in a mathematical library. Whenever you will want to use, you will use it. Suppose you have a data, you have collected lots of data, and the data you are plotting to see how it is. Okay, you have plotted. Then you can also fit the data with some polynomial function or something like that, or some sine function, or mixed with exponential and some algebraic function and some things like that. And then you can conclude that, okay, your this model goes like that, and the function behaves like that, and see the outcome. This is the outcome, final outcome of your modeling, that the data or the system behaves in this way. It is something rising like an exponential and then falling like a power law or whatever. You can tell like that, and then you can make a paper. So whatever you do, you need the help of mathematical functions. Well, the mathematical functions are not here in the built-in modules. For that, there is another module. It's called math. You will soon get to know what are the different kinds of modules and things like that. So whatever module it is here, you just write one mantra. That mantra is import. You just import math here. Okay, you import math here. I go to the option and I can increase even more, so that you can correctly see it. Okay, so import math, remember this. So you see, import is a say Python command, so that's why it's in orange here, and math is the name of the module. So math is imported. How do you know it is imported? How do you know it is imported? It is imported because you can see dir, the same mantra. Since math is a module, you write MA. See, it is showing you actually how to use math, directory of math. That means what is there inside. Math is a library or a module, or you can say it is basically it is a Python program, huge Python program. Inside that there are piece by piece things are written, and you take one piece at a time, one set of programs at a time. So this is whatever you have. See, some of the things you will understand. SQRT will take square root of any number. Tan tangent, tan hyperbolic. Tau is some function. Sine hyperbolic. This is a sine function. This is the value of pi. This is logarithmic base 10. All these are functions actually. All these are functions. You see how it works. Well, so inside math, you have imported math. So that means in your workspace, see, now you see directory. If you see directory, blank directory, you'll see you had built-ins, but now you have math. You see, now you have math because you have imported math now. Okay, and you see lots of things are there. GCD is greatest common divider and so on. Lots of things are already here. Okay. ERF is error function, etc., etc. Ceiling is CEIL, ceiling of a number. Ceiling means upper level, and the floor is the floor. The floor level of a fractional number, and so on. Lots of things. Okay, so suppose you want to see how the sine function works, right? So then you want to type help. I'm telling you, this is very, very common and general for any kind of Python module. Whatever module from wherever you import, these things will be always handy. You have no one to say help around you. You just import the module, check what is there, then check with help what is the particular name of give the particular name of the function, how it works. So inside that help, you don't write sine. If you write sine, say, it won't understand, because sine it doesn't understand. You have imported actually math. So actually you have to write math dot sine. This is the system of Python. That means this is a complete address. The sine is some object. It is inside the math module because you have actually imported math, not sine, right? You have imported math and not sine. So basically, if you write, it will show you this because this is small these things. It is showing the sine is a function. Inside that, you have to give some argument, whatever name of the argument doesn't matter, whatever it is, and the return the sine of x, and the argument is always in radians. Radians means you see the 180 degree is called pi radian, right? So you can convert it in radians. It's mathematically when we actually use mathematical things in computer, we actually always do it in radian. It is useful for us. So that's why it goes. Suppose now you work math. So math is the module name, and inside that there is sine, and give you say some. Suppose you have want to know what is the sine of sine 30 degrees, say for example. Okay, so suppose you give x equal to 30, right? Equal to 30. It is in degree, because in computer you can never be able to give any unit. So understand that 30 is your degree. It's an arbitrary unit. Okay, so it is 30. Now you want to convert it to radian. You know this 180 degree equal to pi radian. So 1 degree equal to pi by 180 degree radian and 180 radian. So we have to multiply this with pi by 180. So you keep it the same name, x equal to x star. Multiply, star is a multiplication, and then pi. What is pi? You can write it 3.14, but you know in math module, if you write math.pi, it will give you more correct, better result value. So this will give you the better and better. You know pi is an irrational number. It will never end. Only approximated by 3.14 something, 1416 or 22 by 7 or something. But pi is actually an irrational number. That means these numbers will never end. It's a very fascinating number. So pi is giving here the pi inside math will give you the some correct up to some order, some levels. So you write x equal to x star math dot pi by 180. By means in computer, by means division, right? So x star math dot pi by 180, right? So this is this. So now write. So it's a radian. So basically 30 degree is 0.52 something radian. Now you write what is the sine. So it is basically math dot sine. So sine function. Inside that you write sine x. So inside that you write x. So that's it. You see, the sine 30 degree is basically half. That means 0.5. So it is giving you that accurate result, 0.499999 up to this. So this is how it calculated. Actually, when we teach students, the first year and physics students, we actually tell them how to write a program to calculate the sine of a number. Sine, it is a some few lines number program. They follow some syntax, follow some mathematical rule. That's called Taylor series, and so etc. etc. R, say R equal to whatever, say area. The area, say you can give it a name, say area. Okay, and then you can use pi, then pi into R, and the square. You can write R star R. That means R square, or you can write R star star. Sorry, star star 2. Star star means power. R square, right? Single star means product, and star star means power. So the area. Now you can write, okay, print, and you can write area. You can give it, but you can also decorate it. Say you can write area equal to, that means you have written a string. Whatever string you have written, like hello world, it will actually reproduce that thing. It will give you that as a prompt. So area equal to, say, variable name is area, right? Okay, that's it. So this is your program. So if somebody tells you, okay, write a program on your students, for the students, if you say they're told that beginners, they have to write a program to calculate the area of a circle. It's okay. If you know the formula, you just do it one by one. So that means you see for all the programs, it goes step by step. The first line is executed first, and it comes to the next. It uses the information here, uses here, and then finally this is output. You can tell this is input. This is my algorithm, but that means it is to be done by now. Well, now I will show you how to plot. Okay, with this minimal knowledge, you can go ahead. I have not shown you the logical loops, etc., but probably in one day it will be difficult. And I can tell Abhishek, you can stop me anywhere in between if I'm monotonously saying things and I cannot see the comments also, if any. So if you want me to stop, I can stop for a moment and then I can resume after. Hi.
Abhishek, you can take up the question from the chat box and ask sir.
Yeah. If you think I can go on, I can go on.
Yes, I have seen the chat box. Some of the questions were regarding the installation that I have answered. I think you can slowly, you can proceed, but a bit slowly, because the
bit slowly.
Yes, you can continue.
Okay, by up to this point, wherever I have gone. So if our colleagues and students are there, if they feel any difficulty, please tell me. I can repeat the things. Okay.
Abhishek, I think for one day, especially for the life science student, it is over. I think because whatever the sir has described, I think that can be first gripped by the student, and some another thing. If the students can demand for further knowledge, then we can arrange another lecture for sir.
Yes, that can also be fine, because
actually in 2 hours everything telling in 1 or 2 hours, it's really when you say it's a huge task.
Because
although
that is also same for me, because I am a
it's not possible for anyone, because we always do programming. That's why for us it is so easy, but for other people, of course,
so
you are not used to it.
I think Abhishek, you can stop up to this, and if there is any relevant question from the chat box, you can ask sir, or straight we can go to the vote of thanks by the head of the Department of Physics.
I can continue. There are lots of things.
Then sir, you can continue another 15 or 20 minutes.
Okay, you will tell me when I have to stop. Okay.
I think you can continue for about 15 minutes. After that, we will take some questions.
Okay. So now I'll show you a very basic thing. One, that's how to plot things, right? So you see in Python. Later, wherever you are in the college, you can also catch Abhishek. He can tell you even more detail. So you can actually, once you are into Python, so whether you do hardcore programming or not, you actually end up in doing everything in Python, like plotting, like data manipulation, like writing hardcore programming, then using some mathematical tools or functions and sets, things like that. So it's once you start writing things in Python, you will see how easy it is to do everything. Okay, so now I will show you how to plot your data. Okay, so the mathematical functions are taken from the module math. Similarly, there are other modules. Lots of modules are there. It's called CMath, complex math. Then there is a module called sys, sys, which controls the system's commands. Then there is a module called random, which takes care of the random numbers, which you can generate random numbers and so on. Okay, so now I can tell you I can show you the how to plot. So there is a module called it is a module, or it is called a package. It's called Matplotlib, mathematical plotting library. Whoever have used MATLAB in your for your work, our sirs and madams, whoever have used for your research, whoever have used MATLAB, this Matplotlib is designed with this. I mean, it is inspired by this. This Matplotlib is inspired. I mean, by this MATLAB. But MATLAB you have to buy. You have to buy this software, and it is not a full-fledged programming language. So many people do on MATLAB and do research works also. But if you are working, if you can work on the Python, it's an open source, and it is a full-fledged computer programming language, so that everything you write here is a computer programming instruction and code. So the Matplotlib is another module. Rather, we'll call it a package, because there are so many modules and the sub-modules and functions, etc. And it is done by third party, not by the Python basic Python official people. This is done by other party for Python, and it is free. You will go to, will search. I will show you how to. First, I have to install Matplotlib over Python. First, you have to install Python. Then you have to install Matplotlib over it for plotting. Like for math, you didn't have to install, because math is inside this here. It's not built in, but it is kept separately. So you just imported math. But now you have to first install Matplotlib, and then you have to import. So suppose the installing part is done. I'll show you later. I can circulate a video also, YouTube video, how to install Matplotlib and so on, because that will take another some 10 minutes. But it is easy, very straightforward. So now I import. The mantra is same. Import matplotlib.pyplot as PLT. So this the mantra is the name is Matplotlib, mathematical plotting library, and it's a huge math library. With this library, you can do two-dimensional plot, you can do three-dimensional plot, you can do contour plot for geographers, you can do image processing, you can do animation, and all kind. You can make film also with this Matplotlib. It's a huge, fascinating thing. You can do lots of things with this. Okay, we'll use, this is the name of the package, right? And under that, it is a PYPLOT, PyPlot, means Python plot. This is a module. So earlier, math was a module, but it is a package. Under this, there is a module PyPlot. And since you have to refer this way with this dot, and we actually basically what we do is that we shortcut is the name is PLT shortcut. Usually we do. You can give it any name. Okay, done. So it is done. Now, if you see what is there in PLT, you can see, because PLT, what is PLT? PLT is basically a nickname of the PyPlot. PyPlot is Python plot. Basically, it does two-dimensional plot. And what is there? It is there in Matplotlib. So the whole thing is renamed as PLT. Okay, so I can see again PLT. Okay, see and the squeezed. See the all these names. See lots of things are there. You can do. First, we'll go. This most important thing is that you have to plot a function, right? You plot some data. So obviously, you will understand there will be some function will be called in the name of plot. Well, let's see. It is alphabetically, right? It's written alphabetically. So PLOT is the most important function. Plot. It plots. Then you'll see lots of things for production quality plot. You can set X level. You can set X limit. You can set X ticks, then you can set Y scale, Y limit, etc., etc. You can set title, all kinds of things you can do. You can write text, all these things. But all the things, you can also plot various small pieces into together. Then you can do subplot. It's a very fascinating. Even with this Matplotlib only takes few days to tell you how you can do. But don't, you don't have to worry. You don't have to learn this separately. What I tell is that you just on your basic mathematical or basic Python this idle, this interpreter, after the Matplotlib is installed, you just write this mantra: import matplotlib.pyplot as plt, and then see, check what is there. What is there inside this plt module. And of course, you see plot is a function. Well, now you know how to check, how to work with plot. You write help, and then you write plot. No, you have to write plt.plot, because plot is inside the plt, right? So plot is a function. Let's see. It will show you 360 lines quiz data in this series. It will show you, just read the first line, plot. It will, you have to give some arguments. Star arguments means you have to, it will later show you the examples. That means you will give more than one arguments. And then you can fix with lots of KWARGs, keyword arguments. Don't have to remember or understand, scratch your head what it is, but rather you come here. See, the examples are there. See, plot plot. Then you give the x data. Then you give the y data. Then you write something here. I'll show you what is something. You may or may not. Then you understand from the lines, that is the line width of the lines that you create. Then you write marker size and so on, etc., and you can begin to plot. Lots of examples, lots of. You can go on and see lots of these things are there. Okay, so you can now show the. I can now demonstrate, and then there are how you plot, what are the markers, shapes and things, colors, all kinds of things will be inside this plot only. Then there are other functions and modules. Okay, so now I write, say x equal to, I created a fake data. Okay, so I created data, say x equal to, say for example, say 1, 2, 3, 4, 5. Okay, and I create another list. See, x is a list, right? X is a list. I create another set of data, say 1, 4, 9, 16, 25. Okay, so of course, as many data will be here, as many data will be here. So x and y are two lists. Not necessarily that they will be lists. They can be tuple or whatever. So two are lists. Now I can write, since I have imported pyplot, so plt.plot and x comma y. Okay, done. So your plot is done. Actually, plot has done. It is showing that plot is done here, but it is not showing on this interpreter. It will show plt.show. Okay, it will show. Actually, it is always it doesn't show, because otherwise you are writing on a code, and inside that you have writing these commands, and you will think that you will actually want to see the plot at the end of the day, but it will not disturb you. Whenever you want to see plot.show, right? Plot.show, it will show you. Okay, so plot.show. So this plot has arrived. So by default, it is a blue color, and it is a line drawing. But you have noticed a bare plot. You can do it lots of things like x and y imported. Now you can write here inside that x and y. Now you can follow the help. The previous you saw the help. You can see the help, or Google is there. You can write is say line width. You can have line width. Say line width is, you can write line width, but you can write shortcut LW. LW is 3. That means 3 times thick. Okay. You can also write with plot with say lines. Dash means lines. Automatically it will plot with lines, but you can also write dash with inverted commas, and say with symbol O. That means I see I can do it 2 times. Okay. So let's see what that means. It will plot with hyphen and O. O means it's a golla. That means it is a bullet. Let's see what it does. It is plot.show. So the plot is this. It is plotting discrete points, and the line also. Now you can do this. You can see also. Okay, you can see also. These are keyword arguments. That means with arguments with some keyword. MS is marker size, right? You see marker size MS equal to, say, for example, say 16, and LW is 2. Line width equal to, say, 3. And you see the color also you can change. Color is, say, red. R for red. Lots of things you can see this. Okay. Now you see this. See, oh, has not taken the red. It will take. So the marker size is increased. Line width is increased, etc., etc. So you can do lots of things. You can do lots of things. Okay, you can. So color, probably it is up to right. C equal to color. So let's see. R for red. You can see see it is a color. So color is red. So you can now set the X title, Y title, then the level, then title, the legend, etc. So lots of things you can do. But probably since my time is almost up, I'll show one more little thing and then I'll end up. Okay. So the plotting, I'll tell you that whoever does plotting, see the other things, whether you will be doing with molecular modeling or so, that things are very special. And you will see that those things are, most of them are the visualizations are often based on this basic Matplotlib, this package. This is very fundamental. Lots of things people do. They see there are other softwares based on Python, Seaborn and other things. You will see they do lots of fancy plots. I won't show anything today. You have bar diagrams, you have all pie diagrams, etc., all kinds of things. So those things are based on all on Matplotlib. Okay. So I suppose this PyMol, the visualization program is also based on this Matplotlib. So I think it is often very useful to learn this Matplotlib by yourself so that you can plot your bare normal data, your data from out of your modeling, and also you can understand how the other visualization software works. Okay. I'll just show you one more beautiful thing, and then I will stop. Okay, another 5 minutes probably. I'm stretching it another 5 minutes. Okay, okay. If no objection, I can continue. So there are lots of, you'll see this based on Python. You will hear some names. There are lots of packages which will be useful for your data manipulation, data visualization, your machine learning work, your artificial intelligence work, and all that. So there are Matplotlib is one fundamental package which does for plotting, and then there are two other very, very fundamental, but particularly one fundamental package that is called NumPy. NumPy is numerical Python. That means all the kinds of numerical data, like the list and the tuple you are using, those things can be handled even more efficiently with this NumPy package. NumPy is also a third-party package, okay, like Matplotlib. So again, you have to install on this bare Python, all these thing, or you have to install NumPy first. Same way, I'll show you just one mantra, and then you just import NumPy as NP. This is a very, very fundamental package. Numerical Python. Numerical Python is NumPy, and we give a code name NP, nickname as NP. Okay, always you can give any name. So NumPy is here. If you write dir NP, that means it will show you all the modules, submodules, functions under it. Lots of things. Each of the thing will take you a day or so. So there will be one function which I'll be particularly useful. That is an arrays. You go to A. I think there will be arrays. Okay. I straight away right here. Okay. I straight away right here. So if you see np.arrays, suppose you write x, right? X is a I wrote already. X is a list. You see the x. Suppose you type x list. Now you write np dot a double r a y s, a double r a y s, arrays and x. Np dot a double r a NumPy. Import NumPy as np dot. What happened? I spelling mistake. A double r.
Yes, I think array. I think it
Oh,
will be
array, right.
Okay.
Array. Okay, np dot array. So see the x is so x was a list. Sorry. So now I convert it as array. So now the type, you see the type x, okay, and you have a NumPy in the array. So ND is n-dimensional array. Later, when you go on using lots of data of different kinds, you will see data can be presented in a matrix form, it's a two-dimensional form, three-dimensional form, and etc. etc. So then you will be using it more often. But I will show one example. Inside this NumPy, see this directory. If you go there, np. So the how it is useful, I'll show you. Here also you have, like in math module, you have sine function, cosine function, and all that. Here also you have the sine function and all that. Okay. So, but thing is that there in math, from math sine, the sine function you gave one argument and it did it work. But suppose if you have imported, imported math and then math dot sine, then you give say 0.5, it will work. But if you give math dot sine, inside that you give x, it will not work, because x is now either it is array or a list. Okay. But in NumPy there are also sine functions. Suppose in the NumPy np and you write sine, that means this sine function is taken from NumPy. Inside that you write x, right? Okay. So now what it does, see, this argument is itself is an array or a list. That means many, it's an iterable. So it's a specialized way. That's the name is called vectorization. You don't have to remember this. But the thing is, the magic is, suppose you want to plot a function, you want to plot a sine function or something, and you have a set of data. You want to check what is the logarithmic of the data. So you can do it at once. Okay. So that the function is such a way designed that the sine will apply on 1, will give this 1 is radian. If suppose the computer will understand 1 is radian, sine will be applicable on 2, it will give you this, sine will be applicable on 3, and so on. Okay. Now I'll show the plot and I will finish. Okay. Let's see. Suppose you create a data, x data, and you create an array np dot. Okay. I just tell you one thing. In list, you have created a list of numbers through range, right? You created some number, say range of numbers, say 2 to some 16,3, etc., etc., and you can put it as a list to tell you that it is a list. It will show you. Okay, this is a list, pure list. But in NumPy, there are similar array generator, where you can actually generate fractional numbers also. That is fancy, right? There is a function called a range. Here it is range. There are many functions, but I'll show you just one and take 2 minutes and finish. Okay, so np dot a range, right? So you go from say 1 to say 15,3, of course it will show you directly this is an array. Of course it's an array, looks like this. See, if I also do that, say np dot a range, its name is a range, that it is range, it is a range. Okay. Of course these and these are same, but this is a list, the category is different. It's the list, and this is a NumPy array. Okay. Also now, just the important thing to tell you that the here you can create also fractional numbers. Suppose you want to create 0.5 to say 10, and you want to go in steps of say 0.4, say for example. Okay. So see 0.5, then 0.9, 1.3, and go up to 9.7 because it can touch 10. 9.7 plus 0.4, it will cross 10 actually. Okay. So this array it has created. Now, with this knowledge, I just plot a sine function. Suppose you create an array np dot a range, and you create say minus 2 pi to plus 2 pi. Okay. So minus 2 star np dot pi. See, the pi is also in np. Pi is in math module, math package, also in math module, and also in NumPy package. Okay. So minus 2 into np dot pi, that means basically 2 pi, comma 2 star np dot pi, comma, say you want to create data, which data will be spaced by 0.01. Lots of data to create. So x. So basically x is a huge array. Now you want to plot say sine function, for example. So y equal to basically np dot sine, and in bracket you write x. That's it. That means all this line function will be applying all the points in x. Right, done. Now you write plt dot plot, and you write x comma y by default. That done. Plt dot show. Okay. Okay. So this is what it is. So it's a sine function. You can now create anything. You could say, okay, I could create say x square into sine into 1.1 by x, etc. So whatever, some bizarre thing you want to create. So you see, you want to see the plot. Oh, it is something peculiar. You can say exponential, like another fancy thing. Say x square into np dot exponential function. Often you will use this. Say minus say x square into it equal minus x, suppose. Oh, then I can write x equal to say np dot a range, say 1 to say something 10, and then 0.001. Okay, and then y this, and then plot this, and then dot show. So this is some kind of function. So any kind of things you can now do this. So if I am to stop, I can stop it here. Thank you.
No, sir, I think you can just mention linspace and then stop.
Yeah. Okay. Good. I intentionally did not do that. Okay. See, there is another important number creator is linspace, linear space you create. Okay. So NP, like a range, it is close to that, but it is a linspace. There are lots of block space also you can create. Linspace, and you can actually go from say 0.5, say up to go to say 5, and you want to create 100 data points. So by default, you'll see start from 0.5, and here you will see it will touch 5, of course, and it will actually create 100 data points. Here it was creating data points. The spacing was 0.01. Here spacing, it will automatically create the spacing. It will decide. By the way, I want to create 100 numbers. So this is your linspace. Okay. See, this is your numbers. See, it goes from 0.5, and goes up to 5, and it is say 100 data points it has created. Okay. So in the earlier example, what Abhishek is right, it has not gone actually 2 pi up to 2 pi, because since it is a range, I could have created it with minus 2 pi to exactly 2 pi, I could have given it, say, okay, I want to create, say, 1,000 points. Okay, then I could write this. Okay, then I could write, okay, y equal to, say, np dot sine, then and so on. Then I could write, okay, plp dot plot x comma y, and then plp dot show. Okay. Oh, I'm sorry. I have to remove it and then. Okay. Anyway, it will show you. So this is what it is. Okay. So can I stop? Okay.
Yes.
Okay. Just to show you, this is probably the second edition of my book. It will be coming soon after this lockdown is over, and I will find it in. I'll actually modifying the book from the earlier edition in a much bigger way, and it will be in the Kindle version also soon in some few days.
Big congratulations, sir.
Thank you. It is my responsibility, I think, since I have got the first this thing, and also I'll get the second edition. Thank you. Okay. I'm open to questions.
Abhishek, is there any relevant
Yes,
question?
there are a few questions.
Okay.
Yes, one of the participants asked, Ankit Kumar Nath, he asked, how can you do close integral using Python?
Yes, you can do. You can close integral. Yes, actually, what we teach students is that Abhishek Babu can tell you better that we actually teach them numerical methods, and the numerical methods we actually teach beginners how to do the integration on computer. That means how to discretize your steps, follow some scheme. It is called, there are very many schemes. You will hear the names like Simpson's 1/3 rule, then trapezoidal rule, and so on. And once you have discretized the function and discretize the integration, and basically integration is actually under the area under the loop. So you have to extract the area under the loop of a function. Once you know the function, you can do that. And then you have the discretized step, and that is your algorithm. You write a 2-3 lines program, and it's done. But in Python, your life is very, very easy, like in NumPy. And then there will be another package called SciPy. There is a module called integrate. There it's just a function. You just write the function that you want to integrate from this to that and do that. Okay, no problem. We can do improper integral. You can do proper integral. You can do anything. You can do differential equations. What a partial differential equations? Anything. Okay.
And another question is that how to plot a figure by defining two different functions in two variables. Can you show us? I think I actually replied that that can be done. I think showing that it will take some time.
It will take some time. I mean, you can consult me later. I'll show you. Actually, you can consult me in WhatsApp. I can, if you're keen enough, I can show you. Actually, the Matplotlib, you have to actually go through elaborately through the Matplotlib chapter. I have rewritten the Matplotlib chapter, and recent times also we have, Abhishek knows that we have actually talked about Matplotlib in various places, so that we got to do lots of things with Matplotlib. Actually, we are also learning day by day. So everything can be done, no problem. Okay.
And I think, and there is another question, probably the last question. Pradeep Bhattacharya asked, can you explain the debugging by commenting? I actually...
no, it is actually debugging by commenting means, actually you debugging is, you have to understand which portion of the your script is giving you the trouble. So you suspect that the first few lines you will check, and the rest of the lines you don't want. So in that sense, you actually let me show you. Let me just a moment to show you. Just test. Say suppose I wrote very silly programs. So I think that maybe I write some mistake. I wrote something. There's a mistake. I don't although Python will actually show you the mistake is here. It's so clever. But suppose I don't find where is the mistake. So I want to check up to this. So I can check commenting. So I can actually comment this up to see this, and I can actually actually put these two things inside this comment. Actually, this is also another comment. So I can put this. I can put another triple quote starts here, triple quote ends here. This is for documentation, and this comment starts here, commenting, and this line is or even a block, for example. Even say this block, or even the block is out of the program. Okay, this way you can block a certain portion, or sometimes you see you can actually give a hash so that this line doesn't work, and you'll check whether the problem is here or some other place. So that is the way you go. Okay, but the best thing, even more best thing is that while you write a program, the good practice is, suppose this is your big file. It's a silly file I have written, but suppose the program is say more than 10 lines or say hundreds of lines here. You are trying to understand the program here. Best thing is that you take one thing from here, copy it, and you can put it. Suppose you suppose here you want to copy this line here, and you put it here, and check whether this works. Oh, this works. It's not saying anything. That works. That means you have the interpreter open, and the program, the whole code is also in front of you. Suppose you've got some new code from somewhere. You are testing this code. You don't understand what this particular line does. You check it. You copy it, place it here, interpreter, and check what it does, or whether it is correct or not. This is the way to go. Actually, this is that means Python gives you the advantage, is the scope that you actually test the program line by line. That's why it is called interpreter based language, right? Okay.
There is the final question. That is, can Python handle every aspect that Matplotlib can do? This is asked by Payal Bonik.
Not Matplotlib, Matlab.
Not Matlab. Yes, she is comparing with Matlab.
Matlab, yes, of course, everything. See, Matlab is basically not a full. It is a kind of programming language, but Matlab is not a full-fledged programming language. But Matlab is, by the way, Matlab is very popular to scientists and the scholars. That's because Matlab, once you get into it, you can actually do fancy plotting, etc., all kinds of things. And also you can write your codes, and you can write your small codes, so that both ways it can satisfy you in both ways. But if you want to be a programmer, and if you are actually, can access the open source program that you don't have to buy, and so it is, and it's ever developing. So why don't you go to Python? So now the Matplotlib, the mathematical plotting library in Python, it is basically modeled over Matlab. Okay, and the another important thing is that once you write a program in Python, and the side by side inside it you are writing actually lines to actually print so plot your data. So everything combined together is actually a Python program, including your plotting instructions. So it is very useful, even compared to other full-fledged programs. Like in Fortran and C, you write a program, then you take the data, take out, and then use GNUplot or something else, and then plot and see. But in Python, you are getting the advantage like Matlab, and also it is a full-fledged program that you can develop your simulation, your any hardcore numerical programming, anything you can do it here. Okay. This is what it is.
Yes. So there is no other question, I think.
Abhishek, please hand over the mic to your head for vote of thanks.
Yes, I think actually I was discussing with my colleagues at Maulana College. Since it is principally for the life scientist, I would like to say a few words about some just application of Python programming that can be done in life sciences, because those applications are quite advanced. And before going to that, we should learn the basics that has been excellently discussed by Professor Abhijit Kaur-Gupta. So I will just mention a few sectors of biology where Python programming can be used. One thing is that, yes. So one thing, Python programming is basically used where there is mathematical modeling of biology. For example, any kind of insect outbreak or disease outbreak, or different equations that appear in population biology. And apart from that, there is also another package that I would like to mention, BioPython, that can be used in particularly in related to some applications in molecular biology. So basically, in applications in biology are quite advanced, and so before going to that, we should first be well versed in the basic part of the Python. Then we can go for it. I can mention the BioPython, and also there is a book by Murray, Mathematical Biology, and interested people can look into it, and it will give a deep insight of how mathematics can be applied. And from the mathematics, where the differential equations and other equations that will appear there, they can be easily solved using Python. So Python has the first application in biology. Okay, that I like to mention this one. Okay.
Please hand over the mic to Professor Shukit Dash, yes, the head of the Department of Physics, for vote of thanks.
Okay, can I start?
Yes.
Good afternoon to all of you. It is my privilege to have been asked to propose a vote of thanks on this occasion. First, I would like to extend our sincere thanks and appreciation to today's speaker, Dr. Abhijit Kaur Gupta, for finding out precious time from his busy schedule and delivering such an excellent and lucid speech, which has made this occasion interesting and meaningful. I'm sure that all of us present here are enriched with his talk. I would like to express our profound gratitude to our principal, Dr. Subhashish Datta, without whose constant encouragement, it would not have been possible for us to organize this kind of event. I would like to convey special thanks to Professor Sudip Dasgupta, Head, PG Department of Zoology and Coordinator, DBT Star College Scheme, for his constant guidance to organize this event. I'd also like to thank all the members of organizing committee for their tireless work, which makes this event possible. I would like to thank Department of Biotechnology, Government of India, for sponsoring our college to organize this webinar. And last but not the least, I would like to extend my warm thanks to all the participants, both from our college and as well as from outside our college, for turning up in such a great number and for making today's session a grand success. With this, today's session comes to an end. Thank you all once again for your cordial cooperation. Over to Abhishek.
Thank you all of us. Dr. Boni.
Thank you, participants, for attending the first day of this webinar, this e-workshop. We request all of you to be present at 2:30 p.m. tomorrow. The link will be sent soon to your respective registered email IDs. We will be discussing tomorrow PyMol and associated softwares for studying biological macromolecules. The session will be conducted by Dr. Shogato Hazra, the Department of Biotechnology, IIT Roorkee, along with his team members. See you all tomorrow. Thank you so much for joining today. Thank you so much.